So these are the steps necessary to complete page 174. So number one, actually numbers 1 through 5, it says use the graph or table to write a linear function that relates y to x. What that ultimately means for numbers 1 through 5 is that you need to write an equation, and all of these are linear. I know these are linear because as y increases or decreases by the same amount, so does x. So like on this one, y is going down by 1, x is going up by 1. Here, y is going up by 2 as x goes up by 3. So all of these on 1 through 5 are linear, which means on all of them we can use y equals mx plus b because every line can be written in slope-intercept form. So on number 1, we need to find a slope, which is m, and we need to find a y-intercept, which is b. So for this first one, to find a slope from a graph, you just look at rise over run. So you pick any 2 points on the graph, and you say, how far do I have to rise and how far do I have to run to get from one point to the next? And that's your slope. So you have to rise 1 and run 1. So the slope is 1 over 1. Rise over run, 1 over 1. So my slope for number 1 is 1 over 1. And if I simplify that, that is just 1. The b value is the y-coordinate of the y-intercept. The y-coordinate of the y-intercept. So the b value for this one, because the y-intercept is 0, 3, the b value is 3. So b is 3. So my equation, when it says write the linear function, my equation, the linear function, is y equals, I'll plug in 1 for my slope, times x plus b is 3. So y equals 1x plus 3. But again, multiplying by 1 does not change the value, so we'll just say y equals x plus 3. Alright, so there is my equation for number 1. Number 2, very similar here. Rise over run, we're going up 2, right 1. So my slope, my m, is 2 over 1. 2 over 1 equals 2. So for number 2, I have y equals my slope. Again, rise 2, run 1. 2 over 1 is 2, so 2 times x, plus b on this one, 0, negative 4. 0, negative 4 is my y-intercept, so I'm going to say plus negative 4. Now adding a negative, if you leave your answer like this, I will accept it, but to me, I'd like to write it as simple as I can. I'd say 2x minus 4 looks more simple than plus a negative, so this is ultimately my answer. On number 3, we're going to do the same thing. Rise over run, you're going down 1, right 2, down 1, right 2, to go from one point to another on the graph, down 1, right 2. So the slope, down 1, right 2, is negative 1 over 2, times x plus b plus b. This one has a y-intercept of 0, 0, so plus 0. If you leave your answer that way, I'll give it to you, but adding 0 does not change the value, so I should really simplify this to y equals negative 1/2 x, and that is it. On numbers 4 and 5, you don't have a graph, you have a table. So as I mentioned before, to find the slope, it's the change in y over the change in x. So here y is going down by 1. So thinking of that graphically, if your y's are going down by 1, here's your y-axis going down by 1, that's going to be a negative. I'll just write my slope separate here. I'm going to go negative 1 is my rise because my y's are going down by 1. And my x's are going up by 1, so I'm going right 1. So down 1, right 1 if it were to be graphed. So negative 1 over 1, that's my slope, which simplifies to, well, anything divided by 1 is itself, so it simplifies to negative 1. The y-intercept on this one, how do you find a y-intercept from a table? Well, I know I mentioned this in class, so to find a y-intercept from a table, well, the y-axis has an x-coordinate of 0. So all of these y-intercepts, they all have x-coordinates of 0. So 0, 3, 0, negative 4, 0, 0. They all have x-coordinates of 0. So on the table, this point right here, 0, 2, must be the y-intercept because x is 0. So 0, 2 is the y-intercept, which means b is 2. And again, that comes from the fact that 0, 2 is on my graph there, on my table there. 0, 2 is a point on the table. So 0, 2 is the y-intercept because x is 0. So that's my y-intercept because x is 0. And again, the b value is just the y-coordinate of that y-intercept, so it's this guy, 2. So the question ultimately says write the linear function, so I need to write the equation. So use this information just like I did up here to write the equation y equals mx plus b, where m is -1 and b is 2. So y equals -1x plus 2, or you could simply say y equals -x plus 2, and that is the answer. But again, if you write it as the one I wrote right here, if you put that as your answer, I'll still give it to you. All right, so number 5. To find the slope, look at your rise, the change in y. It's going up by 2, so my slope is going up by 2, rising 2. My run, the x's are increasing by 3, so my run is 3. So the slope, rise over run, is 2 over 3. The b value comes from the y-intercept. The y-intercept must be 0, -1. Again, I'm looking for x to be 0. That's how I know that 0, -1 is my y-intercept, because x is 0. So -1 must be the b value, the y-coordinate of that y-intercept. All right, so write my equation. Y equals mx plus b, y equals 2/3 x plus -1, or I can put -1. There's the answer. All right, so that's 1 through 5, writing those equations in slope-intercept form, since any line can be written in slope-intercept form. Moving on, 6 through 11 here, it says, does the table or graph represent a linear or nonlinear function, and explain. So let me give myself a little bit more room on here. Actually, I can just clear these up. All right, so here we go. Looking at number 6, does this table or graph, does this graph represent a linear or nonlinear function? For this one, I'm going to say, so for number 6, I'm going to say, let me make this a little bit bigger. I'm going to say for number 6, this graph represents a nonlinear function because its graph is not a line. I don't have to say its graph again, because it is not a line. So if you're given a graph, it's just visually, is it a line or not? If it's a line, it's linear. If it's not a line, it's nonlinear. Number 7, I'm going to say this graph represents a linear function, since it is a line. Number 8, I might as well just copy number 7. It's the same explanation. This graph represents a linear function since it is a line. The one exception where a graph, where it looks like a line but is not a linear function, is if you were to have this graph right here. Let me show you. If you had a graph of a line with an undefined slope, that would not be a linear function, because remember, think back to class when we were talking about functions and how they're like vending machines. This input, this is just a random example, this input of, I don't know, let's just make that like 2. The input of 2 for x has multiple outputs. So that's like saying I'm going to hit the button 2 on a vending machine and I'm going to get out all these different y coordinates. So you're not just getting out one item from the vending machine, you're getting out, in this case, infinitely many items from a vending machine, which would be just kind of crazy. But that would not be a function. Therefore, it would not be a linear function, because it's not a function at all. So that's one thing to keep in mind. This is not a function. Although it's linear, it's not a linear function, because each input does not have exactly one output. All right, let's get rid of that. So let's go back to the assignment here. Whoa. Whoa, I don't want red. Come on, Microsoft Paint. All right, there we go. So moving on to the next 3. It is asking again, is this graph linear or nonlinear, and is it a linear or nonlinear function, and explain. So number 9, I'm going to say, looking at my rise here, I'm actually going down by 2. My run, I'm going up by 2. So this one has a constant slope. So because it has a constant slope, its graph would be a line. All of these lines have constant slopes. Rise over run never changes the value. Whereas like on number 6, if you rise over run, well, rise over run here is 1, and then rise over run here is 1/3, so the slope changes over time if it's nonlinear. Number 9 has a constant slope, so number 9, I'm going to say this table represents a linear function since it has a constant slope. All right, number 10. On this one, my rise, well, for this one, from -2 to 7, I'm going up 9 units. From 7 to 23, I'm not going up 9 units. If I were going up 9 units, this would have to be a 16, and it's not. So this one is nonlinear. This table represents a nonlinear function since it does not have a constant slope. All right, number 11. My y is I'm going down by 3 and then I'm going up by 3. So if you're going down 3 and then up 3, as x goes up 3 and up 3, well, going down and then up, what this graph would look like let me try to find, where was I here? Here we go. If you have 0, 3, 0, 3 right here, and then 3, 0, and then 6, 3. So this is just to give you a visual. This graph, you're going down and then you're going up. And then 9, 6 would be right up there. So this graph is actually a V-shaped graph. So this is nonlinear for sure. You can see it visually, but just looking at your rise over run, you're going down 3 and then up 3. So you're going with a negative slope from the down 3 and then a positive slope with the up 3, down 3, up 3. So down 3, right 3, down 3, right 3, and then up 3. Right 3, up 3, right 3. So you change from a negative slope to a positive slope. That's definitely nonlinear. Get rid of this again. All right, so number 11, I'm going to say, number 11, this table represents, again, I'll just copy it out of here. This table represents a nonlinear function since it does not have a constant slope. And there we go. All right, 12 and 13, the word problems. So for number 12, it says, the table shows the revenue in millions of dollars of a company when it spends some amount A in millions of dollars on advertising. So we've got R for revenue and A for the amount on advertising. So there's my chart here. So this is ultimately like an X and Y table. This is an XY table. They just used A in place of X and R in place of Y, but they still give you this nice table to see all those values. So for part A, I'm going to get rid of all these. For part A, it says, write a linear function that relates the revenue to the advertising cost. Well, that's just like numbers 1 through 5 where it says write a linear function that relates y to x. Well, now you're relating a to r or r to a, but it's ultimately the same thing where you have to write a linear function. So just like I said before, any linear function can be written in the form y equals mx plus b. So that's ultimately what we have to do for part A. So number 12, part A, we're going to write an equation in the form y equals mx plus b, but now I don't have x and y. Again, I have an a instead of an x. I have an r instead of a y, so I need to use r equals ma plus b. But it's still the same idea. It's just they replace the variable x with a and replace the variable y with r. So let's see. To get my slope, I need to still use rise over run. So rise over run. Let's see. The rise, I'm going up by 4. The run, I'm going up by 2. Rise 4, my slope here is rise 4, run 2, which simplifies 4 over 2 simplifies to 2. So my slope m is going to be a 2. My b value, that y coordinate of the y-intercept, still comes from when x, or in this case a, is 0. 2 is that b value. So 2 is b, and that comes from, b is 2, that comes from the point 0, 2, and again, I know that b is 2 because here x is 0, and it's the y-coordinate of this y-intercept. So ultimately, my equation for this is r equals 2 times a plus 2. That is my linear function. All right, part B. Part B says, what is the revenue of the company when it spends $10 million on advertising? Well, when it spends $10 million on advertising, that's A. That means I need to plug in a 10 for A, since these are, it says these are in millions of dollars already. So I'm going to plug in 10 for A to represent $10 million. And then I need to solve for R. So R equals 2 times 10 is 20 plus 2. Just make sure you go in the order of operations. So grouping symbols, there's something to simplify there. Exponents, we don't have any. So we need to multiply or divide left to right before we add or subtract left to right. All right, so here we get the revenue is 22. So what does that mean for this problem? This is a word problem, so we have to write a sentence. So first let's find our units. R is in millions of dollars, so this is $22 million. And then we do have to write a sentence. So this is my answer, but I need to write my answer in sentence form, so I'm going to type this one out. My answer would be, it says, what is the revenue of the company when it spends 10 million on advertising? So the revenue of the company when it spends $10 million on advertising is $22 million. Make that so you can see it. There we go. Oh, Microsoft Paint, you're failing me again. Come on. Beautiful. All right. There she is. So there's my answer in sentence form. All right. So number 13 is the last one we have to do here. So I am going to get rid of all of this. Okay. Number 13, what does 13 tell us, or what does it ask of us? It says the equation y equals 7.9x, 7.9x represents the cost y in dollars. So y is the cost. I don't even know the cost of what yet, but I'm going to define my variables. The cost of buying X pounds of chicken salad. All right, I guess we're buying some chicken salad. Cost of chicken salad. All right, and then it says, oh, I'm sorry. This is okay so far. It's the cost of the chicken salad, but we have to define X as well. It tells us right here, X is the pounds of chicken salad. So X is the number of pounds of chicken salad. Jesus, 2:40 already, and I haven't eaten lunch, and I'm talking about chicken salad. All right, number of pounds of chicken salad. Okay, so we've got our equation. I defined my variables, so I know exactly what I'm talking about and what these represent. It says, does the equation represent a linear or nonlinear function? Well, way to go me. I did all this work, and it's just asking, is this guy right here linear or nonlinear? Well, if it's linear, it can be written in the form y equals mx plus b. So if it's a line, if it's linear, it can be written in that form. If it's nonlinear, you can't write it in that form. So really this question, thank you for giving me all of this about my chicken salad, now I'm hungry. It's just asking, is it in this form? Is y equals 7.9x in slope-intercept form? Well, yes, because you could put plus 0, and now it exactly matches up with y equals mx plus b. So this one, I'm going to say this, I'll say y equals 7.9x is a linear function because it can be written in slope-intercept form, and that again is y equals mx plus b. And that is my final answer. Just circle that, call it a day, and that will be it. There we go. All right. Have a good one. Stay safe. Stay healthy.